In this video, we're going to take a look at your packet for your supplement for section 1.5. And with that, it's applying your transformations to tables and also graphs, but it's going to start with the tables. And for this section right here, starting with number 1, what you're doing is you're comparing one row to another row and trying to see what was done to create the second row. So the original function is always the f of x row. So you're always comparing to this row right here. And if in the first one, we want to know what you would do to the f to get the g. So we want to take a look and compare that to this G row right here. And if you compare that, notice that if you kind of flip the F over on this line right here, it turns into the G because the 4 is over here and now it's over here. And the 0 was here and now it's over here. And the 3 was here and now it's over here. And the 1 is here and now it's over here. So what's happening really is this 2 has a 0 here. It's actually going over and becoming a negative 2 to give you the 0 that's in the table over here. If you, oops, let me erase this so we can see it a little better. If you look at the 1, its value was 3. If it changes its sign and comes over here and becomes a negative 1, you get the 3 right here. So the x's are actually changing the sign, which is allowing you to reflect over that middle section there. So what we have is your g of x is your f of x with the x's changing their sign. So you can see that if we test that out and we start with the first spot, if we plug in negative 2 to figure out what should go here, f of the opposite of negative 2 would be f of 2. If you go over to the 2, the value there is 4, and that's what's in this slot right here. So that is the formula for the G. Now let's take a look for B at the H. And C and D are on the next page, but they're going to look at K and L, and we'll do it here so we can see the equation a little bit easier. So we're going to compare this row to this row. And if you look at these, and you compare them to these, notice that the F values, all the Y values, they're just changing their sign. So rather than changing the sign of the X, you're changing the sign of the Y, which means your H of X is the opposite of your F of X. You're changing or multiplying your F's by negative 1 to get your H's. And so that's what your H is. Now, if we take a look at the C and D, C is asking what's happening to get your K, and D is what's happening to do the L. But we'll stay up here where we can see our table. So if we look at this and compare the F here to the K, and see what could I do to all those F's to get everything that's in the K. Well, notice that this one started at 0 and it went to 6. This one started at 1 and it went to 7. Well, I notice both those are 6 apart. It's like you're taking these F values and adding 6 to them. Let's see if that continues. 2 plus 6 is 8. 3 plus 6 is 9. 4 plus 6 is 10. So the K function is really this F function with 6 added onto it. Now, what about the L? Let's take a look at the L. If we compare this F row here to this L row, notice in the first column we had 0 and it stayed at 0. But then we had a 1 that became a 3. And we could either add 2 or we could multiply by 3 to make that happen. So let's look at the next one. The 2 became a 6. Notice 1 times 3 is 3 and 2 times 3 is 6. Well, does that work with the first one? 0 times 3 is 0, so it seems to work. Let's see if the f's can all get multiplied by 3 to get the l's. 3 times 3 is 9. That's what we have. 4 times 3 is 12. That's what we have. So that L function is really just 3 times the f of x function. And so that's how you can it's kind of like you're doing some kind of puzzle. You're trying to figure out how to turn something into something else. Now that one you were given the table and you had to find the function. In the next part for number 2, you're given the table and the functions, and you have to fill in the blank parts of the table. Now the first 3 are the easier ones. These ones here, the numbers are all outside of the f of x. They're not in parentheses like you see on the bottom ones. So these are all going to apply to the y value. And they're going to do exactly what you think. The other ones down here, those kind of happen to the x value. And so those are going to do something a little bit different. We'll see that happen a little bit later. So let's first take a look at the y values, and then we'll go look at the x values. This first one here is just saying to take the f of x and multiply it by a half. So that means this entire row here gets multiplied by a half. So negative 2 times a half is negative 1. Negative 1 times a half is negative a half. 0 times a half is 0. 1 times a half is a half. 2 times a half is 1. 3 times a half is 3 halves. 4 times a half is 2. 5 times a half is 5 halves. And 6 times a half is 3. The next one here has a negative 2 in front. So this is saying multiply this row of f of x by negative 2. So negative 2 times negative 2 is 4. Negative 1 times negative 2 is 2. 0 times negative 2 is 0. 1 times negative 2 is negative 2. 2 times negative 2 is negative 4. 3 times negative 2 is negative 6. 4 times negative 2 is negative 8. 5 times negative 2 is negative 10. And 6 times negative 2 is negative 12. And so that gets you that row. Now, this last one that affects the y's is this one here, and notice it has a plus 5. That means everything in this f of x row here, we're going to add 5 to it. So negative 2 plus 5 is 3. Negative 1 plus 5 is 4. 0 plus 5 is 5. 1 plus 5 is 6. Notice they're all going up by 1, so we'll have 7, 8, 9, 10, and 6 plus 5 is 11 on the end. So that's all of those. Those are the easier ones. The ones that are a little harder are these bottom ones, and we'll change colors for those. These ones, it's better to off to the side kind of figure out what's going on. This one here, you're applying this to the x. So basically we're adding 2 to the x, and then we have to go search for what value we're going to be putting into the box here. So this first column has a negative 4 here. So I'm going to do 4. F of x is negative 4 plus 2, because that's the x we're plugging in for that column. That's the same as f of x, f of negative 2, which means we go over to negative 2 and we look for what its y value was, which was 0. And that's what's going to go in this box right here. And then when we change it for the next one, the next column is negative 3. So we're going to plug negative 3 in here. Negative 3 plus 2 is negative 1. Find negative 1 up here, and what's its y value? It's 1. So we put it right there. For the next column, we have a negative 2 for the x. You plug that in here. Negative 2 plus 2 gives me a 0. Find 0. Its y value is 2. So that's what we fill in here. If we keep going, the next column has a negative 1. So we're going to put negative 1 here. Negative 1 plus 2 is 1. So we find 1 up here, its y value is 3, so that's what goes in that box. Our next column has an x of 0 right here. So we're going to plug a 0 in here. 0 plus 2 is 2. Find 2. Its y value is 4, so that's our answer. The next column has a 1 on the top of it. We plug that in for x. 1 plus 2 is 3. Find 3. Its y value is 5. The next column has a 2 on the top of it. So we plug a 2 in. 2 plus 2 is 4. Go to the table, find 4. Its y value is 6. Now watch what happens on the next one. The next column is headed with a 3 for the x. Plug in 3. 3 plus 2 is 5. 5 is not on that table. You cannot go beyond the table. Since 5's not there, you actually put an x. Or leave it blank, either one. When we plug 4 in, 4 plus 2 is 6. 6 is not on the table, so same thing. It's an x there. Now, when we learned about transformations, we learned that the x plus 2 in the middle here, this is going to shift things left 2. If you look at your table, all these values for this row here were shifted left 2. You can see that happen there. If you look at the bottom one here, this is an x minus 3. We expect that to go right 3. And notice if we go up here, whoops, let me erase this. And we take all these values here and we shift them right 3, we should have a negative 2 here, a negative 1, 0, 1, 2, and 3. And then because we don't have a 5, 6, or 7, the extra ones here just aren't going to end up being on the table. Now watch when we do that one. If I take this f of x minus 3 and I plug in negative 4, I get f of negative 7. That's not on the table, so it gets x'd out. If I do a negative 3, I get negative 6. That's not on the table. It gets x'd out. If I do the next column, which has a negative 2 for the x, I get negative 5. That's not on there, so it gets x'd out. If I do the next column, which has a negative 1 at the top, negative 1 minus 3 is negative 4. Go to negative 4, you get a negative 2, and watch. When we shifted them right 3, that's what we put in there. So you can actually see in the table all the values going left and right, which is kind of cool. Now, the ones that are left, those are things that are being multiplied by the x's. So if you remember, those are going to be a horizontal stretch or compression. We're going to see that happen in the table also. So if we start with, and I'll do these in a different color. If we start with this one, we're going to multiply 1/2 by the x's, and that's going to give us something new. So let's see what happens. The first one here is a negative 4. 1/2 times negative 4 is negative 2. So if I go up here and I go to negative 2, my value there is a 0. So that's my answer. If I do the next one, the next column has a x value that is negative 3. 1/2 times negative 3 is negative 3/2. That is not on the table, so I X it out. The next x value is going to be the negative 2. 1/2 times negative 2 is negative 1. We're going to find negative 1 and put down its y value, which is 1. If I go to my next column, my x value is -1. 1/2 times -1 is -1/2. That is not on the table, so you X it out. The next column has a x value of 0. If you plug 0 in, you get 0. And so that is going to be a 2 because 0 has a 2 for a y value. If we go to the next column, we have a 1 in it. 1 times 1/2 is 1/2. That's not on the table, so we X it out. On the next one, we have a 2. Plug that in. 2 times 1/2 is 1. So find 1. Its y value is 3. And then when we plug in 3, 3 times 1/2 is going to be 3/2. That's not on the table, so you X it out. And then, whoops, when we plug in 4, 4 times 1/2 is 2. 2 has a y value of 4. So we put that right there. Notice that what happened is these values here, if you took the 2 and then you stretched those out, that's what happened in this row right here. And multiplying by 1/2 is a horizontal stretch. You'll see that when we do the next row, which is the 2, that we're going to get things compressed in. So on the last one that we have here, this 1/2 is now a 2. So if you look at -4 times 2, that's -8, which is not on the table, so we X it out. -2 times the -3 is -6, not on the table, so we X it out. The next row is going to have a -2 for the x, times 2 is -4. That has a y value of -2. The next column has an x value of -1. Multiplied by 2 is -2. So if you look at this, its y value is 0. The next column has a x value of 0. 2 times 0 is 0. 0's y value is 2. And then the next column has a x of 1. Plug 1 in. 2 times 1 is 2. Find 2, and you get 4. So that is your y value here. The next column has an x of 2. Plug that in. 2 times 2 is 4. 4 has a y value of 6. When we get to the next column, 2 times 3 is 6. That's not on the table, so you X it out. When you do 4 times 2, you get 8. That's not on the table. You X it out. If you look at what we ended up with right here, that is these values squished in. Of course, it skipped every other one. This one didn't happen. Neither did this one, or this one. But the others were squished inward toward the middle where the x is 0. And that's what we expected to happen for that. So that's with the tables. Now, this section here is wanting you to kind of identify what the transformation would be to take f and turn it into g. So if you look at the first one, your parent function is this square root. And we can see the square root inside of the g function. And notice that this x minus 7 is inside the square root, which means that you would have an f with an x minus 7 in it. The divide by 4 there, that's like having 1/4 times the square root of x minus 7. So what happens is when you're translating the g into what the f is, you have a 1/4 out front here. So g of x is 1/4 f of x minus 7. And you can see that happen if I took this and put it right in there, and then took this and multiplied it in front, I would get that equation right there. For number 4, it's a little bit trickier to see. We have a 2 on the top right here. We can rewrite this as 2 times 1 over x plus 3. That makes it easier to see that you have a 2 times this and then a 3 added around. So the g of x is 2 times f of x with a 3 added on the end. And that's how you would translate that in. Now, you can write 5 a couple ways. You can leave it like it is here, or you can take this and factor a half out. That makes this 1/2 times x minus 10 inside this part here, which is the square, which is the parent function. So it's up to you whether you want to factor that half out or not. If you do that, then you can see that all of this is inside your f. So you have an f with a 1/2 times x minus 10. And then on the outside of it, you have a -4 being multiplied and a plus 3 being added on. And that's what your g of x is. We can do the same thing for number 6. You can see that the parent is a cube root, and you have this stuff underneath the cube root, which is going to go inside the f. If you want, you could factor a 10 out and have an x plus 3 like that. All of this would be inside the f. And then the 1/2 is being multiplied on the outside, and the -6 is being subtracted off the end. So that's what the g of x is. So that's how you can kind of translate one into the other. And then the last part is on the graphs, being able to do the transformations there. And I'm actually going to zoom in just a little bit to make these bigger, because it's a little bit easier to see the graphs if they're bigger. So on the first one, you just have, whoops, there we go, the 2 on the inside, and that would be like your b. This here is going to be a horizontal compression by a factor of 1/2. Remember, when it's inside, which is a b, you multiply by 1 over b, and that squishes it in towards the y-axis. So what you do is you take all the y coordinates, all the x coordinates, and multiply them by a half. And so this x coordinate is -4, multiplied by a half, it squishes in here. This x coordinate is -2, multiplied by a half, it squishes into there. This x coordinate is 0. When you multiply by a half, it doesn't move. This x coordinate is 2 times a half, it becomes a 1. And this x coordinate is a 4. When you multiply it by half, it becomes 2. And you can see that this compresses this shape inward. Now, the next one has multiple things happening. I would suggest doing it in colors so you can see what's going on. We can go from left to right and do the 2 first. The 2 is on the outside, so the first step would be a vertical stretch by a factor of 2. So we're going to multiply y by 2. So this y value here is at 4. It's going to go up to 8. This y value is 0. 0 times 2 is 0, so it stays. This y value is 4. It's going to go up to 8. And this one here is 4. It's going to go up to 8. And this y value down here is -4. It's going to go to -8. So notice I'm taking all the important points in order to be able to sketch things in. Like that. Now, if we continue on, you can actually do the negative and the 2 at the same time. The negative is going to flip things over the y-axis on this part here. So the negative is a reflection over the y-axis. It changes the signs of the x's. And the 2 is a horizontal compression by a factor of 1/2. So if we do that all at the same time, what we're going to do is it's going to reflect over the y-axis, and it's going to compress horizontally by a factor of 1/2. What we're going to do is multiply x by negative 1/2 to get all that to happen. So this x coordinate right here is -4. If I multiply that by a negative 1/2, it becomes -2. So it's going to flip over and become that one right there. This x coordinate is -2 times the -1/2. It becomes a 1. This x coordinate is 0. It's going to stay 0. This x coordinate right here is a 2 multiplied by a negative 1/2. It becomes a -1. And then this x coordinate is a 4 multiplied by a negative 1/2. It becomes a -2. So you can see that our shape flipped over and compressed inward towards the y-axis. The last thing, which gets us to the final graph, is the -1 on the end. And that's the third thing that we're going to do. That is a vertical shift. And it's going to go down 1. So all of these red points that matter, they all go down 1. And then you draw in the final graph, which is in blue here, like that. So that's how you take care of that one. Now, the next one has a little bit more going on. And I mentioned earlier about factoring things in the middle. So what we might want to do is rewrite this by factoring a 2 out in this middle. That gets you -2 f times 2 times x plus 2, like that. The first thing that we're going to do on this for your first step is going to be taking care of this -2 on the outside, and that's going to multiply all the y's by a -2. When you do that, we're going to reflect over the x-axis because it's going to change the signs of the y. And it's going to stretch it by a factor of 2, excuse me. So if we take this y coordinate, which is 4, and multiply it by -2, we get a -8. See how that stretched it and it flipped it over. This y coordinate is 0 times -2, it stays. This y coordinate is 4 times -2 becomes -8. This y coordinate is 4 times -2, it becomes -8. And this y coordinate is -4. When you multiply that by -2, you get a +8. So you can see that it's much taller and it's flipped over that x-axis. So that takes care of the A, which is out front. The next thing we want to do is take care of the B, which is inside. And the B is a 2, and since it's bigger than 1, it's going to compress it horizontally. So the 2 is going to be a horizontal compression. and it's going to be by a factor. And remember the b, it's always 1 over b, so it's a factor of 1/2 because it's a 2, and you flip that over and it's 1/2. So we're going to multiply x by 1/2. So this x coordinate here is -4, it becomes -2. This x coordinate is -2, it's going to become -1. This x coordinate is 0, it stays 0. This x coordinate is 2, it's going to become 1. This x coordinate here is 4, it's going to become 2. You can see how we compressed in, and it's half as wide as it was before. So you take the blue one and all its x coordinates get multiplied by 1/2. And then the final thing that we do for this one, I'll do it in green, so our final graph will be in green, is this here. And since this is a +2, it actually goes the opposite direction we think. It's going to go left 2. So I'm going to shift all of those x coordinates, and they're all going to go left 2. So that is easiest to see by just kind of moving them across the graph. So this here, if we're going to see this, is we're going to go a horizontal shift. We're going to summarize it. And we're going to go left 2. If it was a -2, we would go right. But it's a +2, so we're going to go left. So that is going to subtract 2 from each of the x's if you were going to do this in a table. But we're going to take the red one, this one here, we're going to go left 2. This one here, we're going to go left 1, 2. This one here, we're going to go left 1, 2. This one here, we're going to go left 1, 2. And then this one here, we're going to go left 1, 2. And what we get is this green picture right here. And that's your final graph for that one. Number 10 is actually easier than the others. Going left to right, we can actually just start with the 1/2. Since that's a 1/2 multiplied by x, that's going to be a horizontal stretch instead of a compression. So the first thing is a horizontal stretch. And that's by a factor of, we always flip the b over. So instead of 1/2, it's going to be by a factor of 2. So we're going to multiply x by 2. It makes it, what's happening is your x's are taking longer to do what they need to because of the half. So this x is -4, it's going to be -8. -2 turns into -4. A 0 times 2 is 0, so we leave that there. 2 times 2 becomes a 4. And 4 times 2 becomes an 8. And you can see that it's stretched out because it's taking longer for the picture to happen. And then the last thing for this is the 2 on the end, and that's a +2, so that's going to go be a vertical shift up 2. So all of these are just going to go up 2 from where they're at. And then you're going to connect them, and this blue one is your final picture there. And that's your supplement for section 1.5.